next presentation is why can't users choose their identity providers on the web?
Hi, I'm Kevin. I work at Orange and INRIA. Really delighted to be here. So I will present our study on OAuth and related data on identity provider used on the web. And the idea is to find why you can't choose the identity provider you trust on the web. So first the problem statement, then a presentation of our study and our solution, one part of the solution. So like explained yesterday, in WebRTC, the signaling goes through a signaling server, and the signaling server can set up a man-in-the-middle attack. So to solve that, WebRTC proposed to use identity providers in the signaling loop to solve the issue of untrusted service. The idea is to add an identity assertion in the session description protocol offers that will assert the fingerprint of the user. So they can be both authenticated without trusting the signaling servers. But on the web, selecting an IDP is a choice issue. The web service, the website that implement social login option, implements really a few of them, often one or two, maybe three. And so the user are faced with a dilemma: either choose an IDP that they may trust, but between a really restricted number of choices, or create yet another account with the issue we know, such as password fatigue or drop in security. So choosing a trusted IDP is impossible. So what's the privacy issue, you may ask? And if you consider the WebRTC identity use case, so the user first log on a website, it chooses to use a social login solution, and then the website initializes the WebRTC connection by using the same identity providers. Then the identity assertion is transmitted to the other users, and the other user browser will instantiate the component called the identity proxy, which will validate the identity assertion. And this allows the identity providers to learn that the two users are having a call together. And so this is a useful information for basically the identity providers is now participating in the call establishment and knows the same information as the WebRTC service providers. So it knows the user call logs, when they are calling and to whom. And regarding the type of warning the user gets, the only warning they get is related to the sharing of their camera. So they may not be aware that the identity providers are getting information about the call. So, like I said, the IDP can learn user call logs, and users should be able to use the trusted IDPs. But the implementation on websites is limiting the user choices. So, in the other end, if the user could choose their IDPs, what would be required for it to be possible? So, the first point is that the IDP and the website must be compatible. Using OAuth 2, the website must be registered on the identity providers, so that they can be so that the website can authenticate to the identity provider. And in some situation, the website may need to trust the IDP regarding the type of data, the level of authentication, the security, or the identity information that are provided. So why is it impossible for the user to choose their identity provider? And we have two research questions. The first one is that maybe the service requires a specialized API, specialized data, so that any identity provider cannot be used. The second research question is that maybe the identity provider do not implement dynamic registration that would allow the plugin of any identity providers or any website on any website. And finally, maybe it's just a trust issue between website and identity providers. So to answer these questions, we did an OAuth study trying to find which type of data are requested by website. And if website mainly require specialized data, I will define it later, or if they require basic authentication data or just user identity. If you use social login, you may know this type of pattern where the identity providers is requesting the user to authorize the website to access some information. In some case, between different scenarios. So on the right, you have GitHub asking authorization to share with Mozilla Developer Network, and on the left, a Facebook use case. So in this case, the implicit authentication is common between the two. Some profile information are also common. But for instance, in Facebook, the website is asking to access the friend list. And so this is obviously not available on GitHub. So in this case, GitHub could not be used by the website on the left. On the right. So this is the kind of specialized data that would block any website to use any identity providers. So in the paper, we categorize the type of API that are accessed between 3 different levels: authentication, which is just a proof of authentication, or maybe just implicit, and an identifiers. A profile data, which we define as being equivalent to what is defined in OpenID Connect standard, and any other type of data, which we call specialized. So in our host study, we try to collect the host to request URL, and these are interesting data because they contain the identity providers, the client website that is making the request, also accessible, also identifiable with a human readable name, and of course the type of data that are requested. So we visited 500 websites and tried to use any social login option that was present, and then collected the host request. And our result, on the left, you have, so we had 2 classifications, because on some websites, the website offers different login options, sometimes only one, and we have a double classification of a minimal type of data that are requested and a maximal type of data. For instance, there is some case where the website implements Google and Facebook, and on Facebook, the website is requesting a lot of data, friend list, more information, and on Google, using Google, they didn't implement the Google API, so just requesting the user identifier and proof of authentication. So on the left, on the blue, it's only one type of service, and then you have the authentication, profile, and specialized class. And so first, this shows that some websites don't need specialized data because, for instance, in this case, the profile and the specialized, it shows that the website is requesting only as a minimal profile data, so just a username and some small information, not really dangerous for user privacy, but is also using with another identity providers a lot more of compromising data. And also, so this kind of only specialized is the type of website that would not be compatible with any identity provider because they require really specialized data to work. For instance, a GitHub Cloud or the kind of data that will not be accessible for any identity providers. And so in total, we have 58% of our website in our study that are at least compatible with authentication or profile data. So it shows that concerning our first research question, the majority of websites could let users choose their identity provider from this point of view. We also look at if the dynamic registration, which is also possible with OpenID Connect, is implemented. And so in our data, we have 500 websites, from which we found 100 relying parties, so websites that are using identity providers. In total, 23 identity providers. And on these, only 5 were implementing OpenID Connect, only 3 with accessible metadata, and none of this metadata were concerned with dynamic registration. So in clear, the dynamic registration and discovery is not at all implemented by modern identity providers. And finally, do websites require trust from their IDPs? We have an example, for instance, France Connect, which is kind of a trusted federation in an identity provider for French services. And basically, the bottom line is that the website that would use France Connect expect some level of trust regarding the user identity. And so this website will not be able to use any identity providers. So can we find some example of this in the wild? We look at the collected data, and we found no example of explicit trust scope that will have some meaning of trust, some type of data that will be trusted by the website that are requesting them. So the hypothesis is that if there is a trust a relation between the website and the identity provider, it's invisible from a technical point of view, and it's probably due to agreement or condition of use. And we didn't study that part. And so our solution to the dynamic registration problem, we had 3 research questions, and we found that dynamic registration may be an issue for users to choose their identity providers. But on WebRTC, the identity solution allows identity provider discovery and without client registration. The client here being the website. So we propose a web browser-based identity management. At the moment, it's a prototype, a Firefox extension. And so the website only put a connect button on the website instead of all the social login option. And the user can then use that button to call an API on the web browser that will display a pop-up and allow the user to choose any identity provider that it may have previously registered on his extensions. So when you select an identity, it's then called the identity provider, which provides a JSON web token with the user identity and his proof of authentication. So we reuse the WebRTC identity mechanism, and basically it shows that if this identity mechanism is used in a while, it could be used more largely for more identity management stuff. Also, and it's not in the paper, but we found it afterwards, there is a web payment working group at the WebRTC, and they are working on a similar solution, but for web payment. So basically, the user configures some payment provider in his browser, and then the website can call an API on the browser to basically do the same flow as we did with identity management and authentication. So in our conclusion, could users choose their identity provider on website on the internet? Basically, it's in our observation, it's not related to the type of data that the website are requesting to identity provider, but more for technical connection between identity provider and website. And our solution could help solve this issue. So thank you.